My name's Simon. Hi. What do I do? I'm a thing called a Databricks Beacon. Who's ever heard of the Databricks Beacons? Exactly. We're like a secret society of people who do lots of Databricks things. Essentially, I talk to the Databricks product group quite a lot about their direction, what they're doing. I'm on the Databricks product advisory board, but I don't work for Databricks. I work for a company called Advancing Analytics, who is just over there. We've got the grabber machine if you come to play with us. But I spend my life talking about Databricks and Delta and lake houses and all that kind of good stuff. I'm a data engineer, essentially. So today we're going to talk about this. How you switch from doing batch-based processing to streaming. What DLT is. This is Delta Live Tables, which is a Databricks feature. So it's a thing specifically within Databricks. So specifically on Spark. And kind of what it is, how it works, how it fits into that world. That is the plan. If this isn't the session you were meant to come to, it's okay, you can leave, it's fine. But yeah, that's the plan. So, first thing first, streaming in Spark. It's a bit of a weird one. So there's loads and loads of stream processes out in the world, loads that are here, that are true streaming engines. Spark is not a true streaming engine. So your deep stream aficionados will turn their nose up, because it's what's called a micro-batch processor. I stole the most boring diagram known to man from the Apache Spark documentation. Now what that means is, unlike a lot of true stream processors where every single record comes in, there's a bit of compute. So every single little record going through, it's doing a real-time update. What Spark does is it runs a micro-batch. It says, like, give me all those changes, process them. And then the next set of changes, process them. Now what that means is, one, it can scale out. So you can do streaming across massive amounts of data because it can get the efficiencies of scale. But it also means it's not as fast. So if you are after streaming, which is literally millisecond latency, don't use Spark. Spark's a parallel system. Parallel systems mean some kind of control node has to talk to some workers, they do some work, they pass the thing up, it goes in a loop. There's always going to be a little bit of an overhead if you're using a parallel system. So it depends what do we say when we say real time. If real time is, you know what, a latency of 4, 5, 10 seconds is fine, great. If your latency is it needs to be millisecond, don't use Spark streaming, that's not what it's for. Now they are running a project called Project Lightspeed, where they're trying to make it faster and faster and faster to compete, but it's not quite there yet. So yeah, you'll see Spark streaming get faster and faster, but for now, have that in your mind. So if you've got your executives are after a real-time dashboard to go on their wall, and it's okay that the latency is about 6, 7 seconds, cool, great, use it, it's good. If you're trying to do something to make a decision to avoid a car crash, don't use this. That's not what it's for. Make sense? Cool. So that's Spark streaming, and it's an interesting idea that kind of has challenged how we build stuff. So back in the day, we had this idea. If I was trying to build traditional analytics, I was trying to build a warehouse, I wanted facts and dimensions, I'd go one way. If I was trying to do streaming, I'd have a whole separate set of tools with a different language, maybe written in Java, so a bit of SQL over there, Java over there. Never the two will talk in the same language. That's kind of traditionally how things ran. Then a guy called Nathan Mars came out with a whole thing we called the Lambda architecture, which is essentially saying, well, I take my traditional batch approach, I take my streaming approach, and I kind of use my stream to top up my batch. So I still got two systems. I've still got two ways of working, but I can get close to real time by stitching them together because simply the tools didn't talk to each other. We didn't have a batch processor that was good at streaming or a stream processor that was really good at doing batch-based big analytical queries. Mainly, streaming would tend to be used for a single thing. I'm building a whole streaming pipeline for this one KPI. Not I'm streaming a generic data model that might go into a star schema that people are going to slice and dice. It's really fixed kind of purpose things we're doing. Now that all changed. And you've got people who go on the Kappa architecture, which is a stream-first architecture, but there's complexity in there for how you actually recover stuff. These days, we tend to do Delta architectures. So Delta is a file format in a lake. It's Parquet with a transaction log, and you can stream into it. So I can use a big batch process to write down a Delta table and then have things stream from that to other destinations. Or it can stream into a Delta table and then batch process from it, or stream in stream. It's very flexible. Now obviously because I'm writing it down to a lake, that's introducing latency. So each hop adds a little bit of latency, but it depends if I care. But what it means I can do is I don't need to have, here's my streaming system, here's my batch processing system. I can actually just have a single system which can do real time, can do batch, it's all in the same language, all uses the same functions, the same engineers can look after it without a separate set of skills. So there's good reasons why we like Spark streaming. Combines things, it simplifies things, the architecture's easy. If you've ever written any Spark, the most easy thing we can do in the world is just write a data frame. So spark.read, format delta, load from this location, that is a batch query. Now, to convert this, there's a load of refactoring we need to do to turn this into a streaming query where we add the word stream. That's it. So in Spark, you can have the streaming data frame versus the batch data frame is literally changing to be read stream. I've got my different options controlling about how often it runs, but all of my transformation functions are the same. All of the languages and libraries I can use are the same. The whole point is, if you've done a load of work to understand Spark, you can do streaming, because it's the same. And that has loads of benefits in terms of looking after our code base, reusing different libraries that we used, having your engineers look at someone else's code and go, I know what that means, because it's the same, but it has the word stream in it. So it's great, benefits. However, one, yeah, micro batches and true streaming, you've got latency, it's not gonna be millisecond speed. But this is the interesting one. So if I've got a stream of data, so if I've got my transactions and they're coming in, I'm getting thousands of transactions coming in every second or minute, and then I've got a product table that I'm also streaming, trying to join those two together gets difficult. Now Spark, you can do stream-to-stream joins, but if you imagine my product table is streaming, and the record I'm trying to join to hasn't changed for a year, I still need to have that record in memory in my Spark cluster. So the temporal nature of streams that you're joining gets really complex. So having a stream and then joining to some static reference data, great, super easy, you can do it. Streaming all of your tables and then in real time stitching it together with various joins gets really, really hard. So that's a traditional problem in Spark. So Spark streaming is good, but it has limitations, and if I'm trying to do facts and dimensions, I'm trying to do analytics, I'm gonna have to join tables together. It's kind of the nature of what we do. So that's our problem. So Spark streaming, been around for a while, not great at doing everything. We switch to the other side of the fence. We've got this thing called DLT, Delta Live Tables. Now, DLT is a declarative framework for doing ELT in Databricks. I appreciate lots of words, but essentially, I can write a bit of code, define some tables in SQL or in Python, throw it all at DLT, and Delta Live Tables will work out, well, that depends on that depends on that, this is the order I'm going to run it into, and it'll look after the full orchestration of it. So it is a way of, it's what Databricks call low code, which just means code to Databricks, which is a bit weird. But essentially it just makes our lives much easier. So DLT is meant to speed up our development. Now, when I run it, I've got a load of things I need to build. So I need to build a little bit of kind of notebooks for it to look after. So I can have a notebook that defines, here's my source table, here's my cleaned up table, here are my different dimensional tables, and I can define it all in a notebook, or in many different notebooks. And I can mix and match through Python and SQL. So I can do the nice repeatable engineering things as Python, and then when I've got my analysts and they're defining the different logic, they can write it in SQL. I throw it all at Delta Live Tables, it figures out dependencies, and it builds it all out for me. So there's lots of nice things inside of DLT. Like the code, really not that different. If I'm trying to write the SQL side of Delta Live Tables, create or refresh a live table. That's it. So rather than create table in SQL, it's create or refresh a live table that tells it it's a DLT, Delta Live Tables, bit of functionality. And then in here I'm just doing a CTAS, select star from, so create this table as select star from, and in this case, I'm loading it from JSON. So we can actually do some basic things. I can then create a table called my next table that's referring to my original table. So just the fact that I've referred to the name of another table, Delta Live Tables works out the dependency between those two. It knows it needs to process that one first, then the next one. And the nice thing about Delta Live Tables, you can run it in batch mode, or you can run it in streaming mode. And actually, it always runs as a stream. So even if I only trigger it daily, it spins up the streaming engine, streams one to the other, streams one to the other, and then shuts down the stream. So it's built kind of with streaming in mind in the background. It's stream-first technology. So it's kind of nice. And, you know, your analysts, if they're used to writing SQL, they're used to creating tables, it's not exactly crazy syntax to get them to start thinking about. Now, on the PySpark side, it's a little bit different. So yeah, I've still got my data frame equals spark.read.json. The only difference, there's some decorators. At DLT table means I'm defining a streaming table it's going to use, or actually a materialized view. So yeah, I need to learn a little bit of syntax, but the syntax is fairly slim on top of what's already inside of Spark. Now, if I do all this, so I've defined some tables in SQL, I've defined some tables in Python, I've thrown that into a Delta Live Tables pipeline inside of Databricks, I'll see something like this. It'll work out the dependencies, sorry, that's not a great photo. It'll work out the dependencies, it'll work out the schema of each one, it knows this column goes into that column, it'll automatically do all like the telemetry, the auditing. I'll get an event log saying I read this many rows. It's got a data quality framework built in, very similar to Great Expectations. So I could say, I expect that this column's not null. I expect if this is null, reject the row and kick it out. If this is null, don't do anything with it, but let me know that I've had some problems. Loads of nice features inside DLT. It's quite good at that kind of stuff. So that's kind of where we are. So Spark streaming, it's good. It's micro-batch, it's got some limitations. DLT has a load of stuff baked in that helps us. Why should you use DLT for streaming is the point I'm going to get to. So, what are we doing it for? 3 reasons. 1, it's stream first. It is built as a stream. So even when I run it as a batch mode, in Spark streaming, you've got this thing, if you're building your PySpark normally outside of Delta Live Tables, you have a trigger. And that trigger can be every 10 seconds, every minute, every 3 minutes. You say how long should each micro batch last? So if it finishes processing, it goes, oh, okay, I'll just wait for another minute and then I'll kick off the next micro batch. So you've got some control about how often it's spinning away, right? But one of those trigger types is available now. Just catch up. So I want you to start the stream, keep doing micro batches until you catch up to where you were, and then stop. So if I don't want my cluster turned on all day, constantly costing me money, but I want it to still just work out what it has and hasn't read, Spark streaming has a checkpointing. It knows what it's already read. It's not going to go back and try and read the same record. So I can just blindly say, right, start, catch up to wherever you need to be, and then stop. And I don't need to configure the watermark. I don't need to tell it what it has and hasn't read. It manages that itself. So the fact that that's baked in to Delta Live Tables, just in terms of how it works, is nice. It makes my life easy. But these 2 things solve a lot of our problems. So Autoloader is a streaming technology inside of Databricks that allows me to stream from files in a really intelligent way. So if I've got a mix of sources, some of it's coming from Kafka or an event hub and proper streaming sources. Some of it is just people are dropping files, and I don't know when they're going to drop a file, but as soon as a file arrives, I need to process through and get it through as immediately as I can. That's what Autoloader is for. So we'll talk a little bit about Autoloader and how that works, and it's inside of DLT as well. And the materialized views is kind of how we do that stitching things together on the fly. Again, also exists inside DLT. So we can bring these things together to solve all of our problems. So Autoloader, what does Autoloader do? Specifically in Azure, you can use Autoloader in Azure or AWS, GCP, etc. But GCP, maybe. I need to check that. Definitely in Azure. What you have is, there's a thing called Event Grid. An event grid is just a messaging system that sits behind all components in Azure. Whenever someone creates a database, adds a file to blob storage, deletes something, changes a setting, whenever you do anything in Azure, it fires off a message in like the backbone architecture of Azure. That's called Event Grid. And so Autoloader uses this to say, well, someone's dropped a file. That's going to put a message into the default topic. And I can subscribe to that. So I can say, actually, I want to watch this blob storage in this particular path. If ever a file lands in it, just put a message in a queue. Now, there's a reason it does this in terms of Spark streaming. You can point Spark streaming and say, just stream from this file location, and it'll read every single file. And then it'll look at its checkpoint against every file it's ever written. So if I've got like 100,000 files, and I'm checking 99,999 files to find the one thing I've not streamed, it just gets slower and slower. Every micro batch is having to list all files, compare it to all files. With Autoloader, because instead it's that, oh, there's something new, I'm going to put that into a separate queue. All I need to do is have a look in that queue and say, have any files arrived since I last did a micro batch? Much more efficient, much faster. Nice way of streaming lots of files when it's going to be a high volume. So Databricks, when I do an Autoloader job, basically going to come in, instead of looking at that list of files, it's going to check what's in the queue, go, file 4. Well, I've already read files 1, 2, 3, I don't need to worry about that. I need to go and read file 4. Much more efficient. So Autoloader is baked in, and I can use Autoloader just as any normal DLT table. Stitching together, files arriving, events arriving, all that stuff makes my life much easier. As a quick snapshot of what it looks like, Spark.readStream. Autoloader is a streaming technology. You have to be doing read stream if you want to use it. And then instead of saying I'm reading a JSON file, I'm reading a Parquet file, whatever, I'm reading a Cloud Files type. Cloud Files is Autoloader. I don't know why they didn't name that Autoloader or rename Autoloader to Cloud Files, but they're the same thing. So whenever you see Cloud Files in Databricks, that means you're using Autoloader. It's a specialist streaming technology. I need to tell it, actually, the thing you're looking for is going to be JSON files. So when Autoloader works, it's looking for JSON or Parquet or XML or whatever it happens to be doing. I need to tell it whether or not it should be using that event grid queue. Should it be using the efficient mode, right? Whole load of other benefits of Autoloader, but that's not why we're here. For doing efficient file streaming, that's what we can use. Now, the other thing that sits on top of it is this idea of a materialized view. So I've got DLT, I've defined a load of tables, I'm using Autoloader to stream in files, I'm using a straight Spark.readStream over event hubs or whatever. How do I stitch all of that together? I've still got that problem of multiple different tables joined together isn't efficient in streaming. That is the final piece of our puzzle, this thing called a materialized view. So materialized view, I know they exist everywhere. Every database has a form of materialized view. This is a specific one inside of Spark, but it does that same idea. It's an incremental write-down of the logic each time it refreshes. So every time a micro batch runs, it says, right, how does this latest bit change if I don't have part of it? Maybe my product hadn't updated, my transactions had. It's going to look inside there, stitch things back together, and just do the updates. And again, create a refresh materialized view. And I can do it in Python, I can do it in Spark, in PySpark, SQL, those things. But that's going to be constantly running, constantly going back and updating it, writing it back down to the lake. So if I'm trying to do things that are fast, I'm trying to get things that are constantly streaming in, it's not that hard. Again, compared to a lot of very specialist actual streaming technologies, this is using the stuff we've already got. It's slowly working through those issues and just fixing them, adding this feature now fixes that problem, this feature fixes that problem. It's still not going to make it millisecond fast. It's still not appropriate for all streaming technology. But if you're not trying to be millisecond fast, you want things updated in real time. If you're doing the kind of real-time dashboard where they look at it once a day, but it still has to be real-time, all of that stuff you can actually stitch together with this kind of stuff. And that's all I really wanted to talk about. So, thanks everyone for coming. If you want to come and see us, we are the stand just behind you at Advancing Analytics. I'll catch you next time. Cheers.